All right, this video is to help you complete the lab forms of the quadratic one. And on the top of the lab here, you'll see I've written down both forms. This is from our video before. We have our zeros form, which is y equals a x minus box times x minus box. Now I want you to realize that when you put your roots in here, it's going to change the signs. And remember, roots are a number 0. So you need two roots to be able to do this where it crosses the x-axis. And you're going to need one more point. So you need a total of 3 points on your graph to be able to use this zeros form. So after you throw the roots in, you're like, okay, that's cool, but you need to know one more point to see whether your graph is going to open upwards or downwards. The vertex form is this form over here on the side where I have x minus h squared plus k. And remember, the hk is your vertex. Again, the sign is opposite in the parentheses. So you need to have the vertex or the turning point and one more point. So this form only requires two, the vertex and one more point. The zero forms requires both zeros and one more point. So I'm going to start and do a couple of these in the lab for you, and then all the work is there so you can work it out at home. So here I have, it says find the formula for the quadratic function. So I know it's a quadratic with zeros at x is 1 and x is 2. So if they tell you there's zeros, this is the point 1, 0, and this is the point 2, 0. And they gave you the vertex. So you're like, wow, I have actually two choices to come up with this. I could do this using the zeros form, or I could do the vertex form. So on this one, I'm going to do both ways so you can see how this is done. So the first one is I'm going to do the zeros form. So we're going to do the zeros form first. So I'm going to kind of make this into like a little table here. And then I'm going to do the vertex form over here. So you can see that you're going to end up with the same parabola. If you were to graph it, they'd be on top of each other, but they might look a little bit different. So here's how the zero form works. I write down y equals a x minus box, x minus box. Okay, and I look and say, oh, here's my two zeros, 1, 0, and 2, 0. So I'm actually going to throw the 1 here and the 2 here. Now they're both positive, so look what happens. They turn negative. I have y equals a, x minus 1, x minus 2. So far I've got a quite good handle on what the formula is. But I need one more point to figure out what my a is. Does it open upwards or downwards? And they did give us a vertex, and the vertex is 3/2, -1. Isn't this an x and a y? So what I'm going to put in the y spot is -1. In the x spot, I'm going to put 3/2. And then I just keep going with my formula. When I do this, I got -1 equals a. When I do 3/2 minus 1, that's a half. 3/2, this should be -2. Sorry about that. This should be -2. And when I have that, 3/2 minus 2, that's a -1/2. After you do this and multiply this through, I want you to put it in front of the a, so that's -1/4 a equals -1. Now, if I want to solve for a, I know they're hooked by multiplication. You can say I'm going to divide by -1/4, but really, we're in pre-calc now. Just multiply both sides by the reciprocal, which is -4 and -4. That will turn that to a 1, and my a is 4. So now my zeros form, so I'm going to put this at the top of my box, is y equals 4 x minus 1, x minus 2. So I found a formula for that information, my two zeros and another point. Now I'm erasing this right here. I'm going to do the vertex form. So that's y equals a x minus h squared plus k. Now the reason why I can use this form, because I also have a vertex. So I'm actually going to throw in the h spot and in the k spot, I'm going to throw the 3/2 and the -1. Now remember, when I throw -3/2 in here, positive 3/2, it turns negative. So it's going to be x minus 3/2 squared. And if I put a -1 in that spot, it's -1. So that one doesn't change sign. So again, I have a pretty good handle on what this formula would be, but I've got to find a. So I get to pick just one of the other points. So I'm going to pick 1, 0, or you could pick 2, 0, doesn't matter. I guess I'll use 1, 0. So I know y is 0, a, and x is 1. So I'm going to plug those in there. Now, this is squared. Please don't forget that. So I'm going to show you a little trick. When I do this, 1 minus 3/2 squared is a negative a half squared. Okay? I'm going really slow. When I square negative a half, negative 1/2 times negative 1/2 is 1/4, or you put in your calculator in this. I want you to be careful to put the 1/4 in front of the a so that you solve this correctly, because a lot of times I have people trying to put this together and you can't. This is a term and this is a term. So I'm going to add 1 to both sides. So I have 1 equals 1/4 a. Then I'm going to multiply both sides by 4 because I'm in pre-calc. I don't need to divide by 1/4. So I have a is 4. So now I came up with another way to write this is y equals 4 x minus 3/2 squared minus 1. So one or the other is correct, and they're both. So what I did here, just so you can see, is I actually graphed both of these. So I'm going to bring up my graphing calculator. And as you can see, here's the first one. Here's our vertex form. Here's the zeros form. Notice I only see one parabola because they're mapped one on top of the other. You can't see the blue. I did that one first and then the red one because it's the same equation. It's the same quadratic. This one just tells me the roots. So it crosses at 1 and 2 and it opens upwards. This one tells me that my turning point is 3/2 negative 1, which is, ready, 3/2 negative 1. All right. So it tells you that different information. So I just wanted to show you that it's the same parabola. Okay. Now the next thing I'm going to do with you is number 2. Now this is another kind of problem that I'm going to have you do that is kind of a nice summation of everything we've done. So I have this equation here, y minus 12x equals 2x squared plus 19. The first thing I want you to do is to get everything on one side here so I can write it like this, y equals 2x squared, and make sure it's in descending order of x, plus 12x. By moving it over to that side, it turns positive, plus 19. Once it's like this, it's very easy to graph, and we're going to graph it in a minute. So I'm going to set up my table because I want you to graph this. This is my x and my y. Okay? And we're going to fill in the table in a minute, and we're going to graph the graph. Before I even start, let's talk about what we're going to do. We're going to find zeros or your roots. Okay, this is what we're going to do here. We're going to find the y-intercept. Now, the y-intercept I'm going to star because this is the only one that you don't really need to show me any work because I know the y-intercept is 0, a number. And I look at my original function here that if I put a 0 here, it would only be 19 because remember my c or my term there is my vertex. My y-intercept. So it's the point 019 is my y-intercept. I don't care if you show me work on that. That's perfectly fine by me. That's the only one. When we try to find the vertex and the axis of symmetry, this is where you're going to complete the square. So we're going to do factoring or the quadratic formula for the zeros or roots, and we're going to complete the square for that. So the only one that you don't really need to show a lot of work for or much at all is the y-intercept. Okay, so the first thing is we're going to graph this, and I actually put this in my graphing calculator, so let me go to my next one here, and I graphed this. So after I graphed it, and I knew that it crossed at 019, so I kind of changed my window up here to 25, and I wanted to see the turning point and everything. And there's one thing I want you to notice about this, it's floating. So if it doesn't cross the x-axis, then I know that the roots or the zeros are going to be imaginary, so that's important to notice. But I want to graph this, so I'm going to bring up my table. So I'm going to do Control T and bring up my table. And when I do this, it looks like negative 3, 1 is my turning point or my vertex. So I actually go there and write negative 3, 1 in the middle, and I put it in the middle of my table. So if you do that, see how that's negative 3, 1, then it repeats and repeats. So that's what we're going to do. So on my table here, so I might have to go back and forth a little bit. I'm going to put, whoops, go back. Okay, so I'm going to put negative 3, 1 right in the middle, and then I want to go backwards 3, negative 4, negative 5, negative 6. So I always go back 3, and I always go forward 3, negative 2, negative 1, 0. Well, the way this works, if you put your vertex in the middle, and it happens to be on a nice point, you're going to see a repeat, a repeat, and a repeat. All right, so if I go back and look at this, see how I see 3, 3, and a 9, 9. So I'm going to come back here and go, okay, I can put this here. So this is 3, 3, 9, 9. So this, because it's very symmetrical. And I know it's 0, 19, so I know it's negative 6, 19. That's also on my table. I just don't want to keep going back and forth for you. So we're now going to graph this. So I've got negative 3, 1, and I've got negative 2, 3, negative 4, 3. Then I've got negative 1, 9, negative 5, 9, and then 0, 19, and negative 6, 19. So when you do that, just kind of swing a nice little arc through that. I always try to do a nice job when I'm online like this. So I have graphed my parabola. Now, I already know right here, oops, I didn't mean to do that. We'll undo that. I was going to underline it right here. I already know that negative 3, 1 is my vertex. And my axis of symmetry is going to be x equals negative 3. But I'm not going to write it here because this is a good check. Here's my y-intercept. I already have that there. So I've got to show algebra to justify the negative 3, 1. So we're going to complete the square. So underneath here, I have a spot for you to do all your work. So we're going to complete the square to come up with a negative 3, 1. So I have y equals 2x squared plus 12x plus 19. And we've been doing a lot of these. So we're going to complete the square. So I'm going to factor out the 2. When I do that, that's x squared. 12 divided by 2 is 6x. 19 divided by 2 is 19 over 2. It doesn't go in evenly, so I'm going to leave it like this. Y equals 2. Now I'm going to force it to complete the square, a perfect square binomial. Take the variable, keep the sign the same, half the middle. Oh, it's nice. Then I take whatever this is, because I've added a 9 to it, subtract the 9, and bring down the 19 over 2. I know I'm going a little bit fast here, but we've done a ton of these, so this is, you got to make sure you're comfortable with being able to do this, because we're forcing it to look differently to get more information. Now I have y equals 2, bracket, this is going to be x plus 3 squared, and then when I put negative 9 plus 19 halves in my calculator, I get a positive 1/2. Now I have to multiply through or distribute the 2. When I do that, it's 2x plus 3 squared. So you don't touch that. You're just basically putting it in front. And 2 times a half is a 1. And I'm very happy because that shows me my vertex. Remember, it's always opposite. It's negative 3, 1. So I can actually come up here and say, yes, it is negative. Whoops. Let me erase that. So I can actually say it's negative 3, 1. I don't do that until I make sure I got my algebra all done. So it's negative 3, 1. And I know my axis of symmetry is x equals negative 3. It has to be whatever my x value is. And if I look at my graph, when I do this, there's my axis of symmetry. That is x equals negative 3. So I just found all that, so I'm very happy. The last thing I have to do is to find my zeros or my roots. So what I'm going to do is I want to know when y is 0. Now I get it's floating. I get it doesn't cross. I also get I'm going to have imaginary numbers. So that's okay. So I'm going to do 2x squared plus 12x plus 19 equals 0. So it's going to be a little bit of review, and some of it's going to be a little bit of nice practice. So I'm going to stack and rack. A is 2, B is 12, C is 19, and when I do my discriminant, my D, my B squared minus 4AC, B squared is 144 minus 4 times A times C, and when I put that in there, I get a nice little negative 8. Now I'm not concerned because negative 8 doesn't surprise me because my graph isn't crossing the x-axis. So I go x equals negative b plus or minus square root b squared minus 4ac all over 2a. Hope you're not sick of me singing that already. I've been doing it every single time. So I look at this and say, I want to simplify this. So I know 8 is 2 cubed. So I'm going to write it like this, 2 squared times 2. And don't forget, I also have a negative 1 in there because it's a negative 8. Okay? So I know this can come out and this can come out. This can come out as an I, this can come out as a 2. So I have x equals negative 12 plus or minus 2I radical 2. So the 2 squared can come out as a 2. This can come out as an I. That 2 has to stay underneath the radical all over 4. And then I come down here and say, oh, I can simplify even more because 2 goes into all of these. 2 goes in there once, 2 goes in there twice, 2 goes in there 6 times. So x equals -6 plus or minus I radical 2 all over 2. And those are my roots. So I'm going to come and put that up here. Okay. So x equals -6 plus or minus I radical 2 all over 2. So those are my roots. So I just kind of showed you how to do step by step one of these larger ones where you're doing everything on there. So I will do more videos if you need more help. I just want to make sure also that if you look at the rest of this, 3, 4, and 5, it says give a possible formula. The 2 that you're going to choose from again are your zeros formula, and the other one is your vertex formula. Okay, so you have to look and see what they gave you. Don't make up points. So if I look at this first one here, they gave me the zeros. I'm going to use the zeros formula. Look at this one right here. They gave me the vertex. I'm going to use the vertex formula, and I have an additional point there. And for 5, they gave me the vertex. I get that and another point. But also, I just want to show you this. This is kind of cool. If your parabola is tangent to the x-axis, that's when your root doubles. So you could actually use the zero forms on this and just use your x minus 2, x minus 2. You can use it twice because it's there. So this one you actually have a choice. So both of them work here. All right, they both work here. This one is my vertex form because that's all I was given. And this one I was giving my zeros form. So go through, see if you can do it, put your answer in the box, and check when you get done. So that's the end of this video.